Continuing on with our notes for today for 7172 graphing, let's start back from this last example that we just talked about. We said specifically we needed to make sure and remember that we always reference this b, that it told us what kind of an equation it was. We said in this first example over here that b was 1/2, because that's what the x is attached to, and since it was 1/2 and it was less than 1, that we knew it was going to be descending and it was going to be a decay function. Then we came back over and referenced the second one, and we looked at our power of x and noticed that attached to it was a 3, and we said since that was greater than 1, that we knew this was going to be ascending or be a growth equation. Now, going back to the other one, we said this line right here, this purple line, was our equation. And we said we had to be careful because it looked like it was a growth equation, but it's really not a growth equation. It's flipped across that asymptote. And that's what this negative up here at the very beginning does. It takes our equation and it flips it. So if we were to flip it back up, we noticed that this dotted line would be our original positive equation. And it's going down, so that's decay. So looking at this second example, I have a negative up here in the front. So since there's a negative, I know I'm going to be reflected across my asymptote. So I have to be careful when I'm drawing and when I'm referencing a growth or decay. So I type this in my calculator, -2 times 3 to a power of x, and I get an equation that looks like this, without that little curve. Now, again, that negative means it reflected across our asymptote. Our asymptote, again, for this question is the axis. So I'm going to draw my dotted line going across the axis. And if I were to think of this in a positive manner, this equation would be this dotted line up here. And if I look at this, I am going up. That's why this is a growth. So even though my reflection is down on the bottom, this is still a growth equation. Okay, so let's look at what we have now. Our domain, same thing as before, nothing has changed. Our arrow over here is going to continue to go to the left. Our arrow over here is going to continue to slowly but surely, it's going to keep going to the right. So our domain is still -infinity to positive infinity. Our range now, like the first example, has flip-flopped because I'm going down. So my range, again, remember, is my y's. So this arrow is going to keep going down, and it's going to keep going down towards -infinity. And then when I look at how high it goes, this dotted line, remember, is not actually there. So I actually don't have anything up here on the top. As I go up and I'm referencing my y's, the last place that I have is my asymptote. It's stopping at my asymptote. So I go down to -infinity. I stop at 0. And again, remember that since this is an asymptote, I don't actually touch that 0, so I have parentheses. Now, my asymptote, again, remember, is right on that axis, so my asymptote is y equals 0. Y-intercept, again, remember, is when x equals 0, so I have -2 times 3 to a power of 0. Anything to a power of 0 is 1. -2 times 1 is -2. Hence the reason when I'm looking at my graph, I cross at 0, -2. Now, going on to our general forms. This is our general form for an exponential function. Reference it back to every function that we've talked about in the same form. We had parabolas where we had a x minus h squared plus k. We had absolute value, y equals a x minus h squared plus k. We've dealt with several functions with h's and k's, and they've all had the exact same shifts. We've even done square roots and cube roots, where we've had an a square root x minus h plus k. They all have the same shifts. This k, no matter what kind of a question that we have, this k is going to have the same shift as this k. The h that is paired with the x is the same thing as what we have here. So when we look at our shifts, don't let yourself get confused. It's the same kind of shift. The parent function, we're always going to call y equals ab to the x, so that's without the shifts. That's without our h shift and without our k shift. Now, that k, it's on the outside. And remember, no matter what kind of an equation it is, if it's on the outside, that's our up and down. So that is our vertical movement. That h, the one that's on the inside, that is our horizontal or left and right movement. Now, remember, this is always x minus h, no matter what equation you're looking at. And so since it's x minus h, it is always going to be opposite, just like we've done in the past. So don't forget that. Our asymptote's going to be moving with our shift. And remember, your asymptote is a line that goes left and right. And what we've looked at so far, it's always been on that x-axis. So when we look at our asymptote's going to shift. It's either going to shift up or it's going to shift down. So when I reference my asymptote, I'm shifting up and down. So that's the vertical. So my asymptote is always going to match that k, always. So whatever that k is up in your equation will always tell you what your asymptote is. So let's look at two more examples. The first one, y equals 2 times 3x minus 2, power of x minus 2 minus 2. First thing, growth or decay. Remember our general form, y equals a times b to the x, and we said growth or decay was dependent upon this b, whatever's attached to that x. So when I'm looking at this equation, this is a 3. So greater than 1, so that 3 tells me this is a growth. Now, second thing, we just talked about asymptotes a minute ago, and we said traditionally our asymptote's on that x-axis, but we're going to shift everything based on these two right here. This -2 on the outside tells us we're going to shift everything that -2 on the outside, remember, is our down 2. This -2 right here up top, remember, that's our opposite one, so we're not actually going left. We're going to be going right 2. So when I'm thinking about my shift, instead of being an asymptote at 0, I now have an asymptote that is up. I'm sorry. I'm going to erase that. I now have an asymptote that is down 2, which is what we said. So erase my mistake and go back. We said that -2, then it was a shift down 2. So my asymptote is now down at -2. So my asymptote itself is y equals -2 now instead of y equals 0. Second thing is my y-intercept. So again, y-intercept every single time. In order to be a y-intercept, x has to be 0. So plug it in, let's see what we get. We plug it in, we get 2 times 3 to a power of 0 minus 2 minus 2. Well, 0 minus 2 is -2, so I have 2 times 3 to the -2 minus 2. Negative powers, hopefully you remember, when we have negative powers, we have to bring them to the opposite sides. This was on the top, so I got to bring it down. So this is 2 over 3 squared minus 2. 3 squared is 9. 2/9 minus 2 is, and again, if you're not good at fractions, make sure you're using your calculators. 2/9 minus 2 is -16 over 9. So when I'm asked for my y-intercept, I am at 0, and -16 over 9 is just shy of -2. And then I can graph this on my calculator to help me with the rest. I know it's a growth. We've already said that. So my growth has to start at the asymptote, has to cross through that y-intercept, and since it's a growth, we know we're growing up and we're growing to the right. Now finishing this off with domain and range. Again, domain, nothing has changed. I'm going left, I'm never going to stop. I'm continuing to the right, I'm never going to stop. So -infinity to positive infinity. My range, now that I have my shift, my range is going to change, so I have to be careful with that. There's nothing down here on the bottom. My range starts at my asymptote. It's always going to start at your asymptote. So my range starts at -2. Remember, we do not include the asymptote, so that's a parenthesis because it never touches the asymptote. And then this is going to continue to go up and up and up and up and up and never stop. So we continue to positive infinity. Okay, let's look at one more. Growth or decay. Again, my general equation, y equals a times b to the x. So I'm looking at my b, which for this question is this 3 over 5. 3 over 5 is a fraction, but the 3 on top is smaller. So that means this is less than 1. So this is a decay. So that's telling me what my picture is going to look like. Asymptote, again, remember that always matches your shift. That always matches your k. So my k for this one is 1. So my asymptote is y equals 1. So I'm going to go ahead and come over to my picture, draw my dotted line, draw my asymptote, y equals 1. Then I'm going to find my y-intercept and use those two to graph again. So y-intercept, when is x equal to 0? So I have 2 times 3/5, 0 minus 1 plus 1, which is 2 times 3/5 to the negative first plus 1. Again, negative power, so that technically belongs on the bottom. So 2 divided by 3/5 plus 1. Type it in your calculator. You get 13 divided by 3. Okay, and if you don't know what that is, type that in. Make sure you know what that is as a decimal. 13 as a decimal, 13 divided by 3 is about 4.3333333. So I'm going to come over to my picture, go up to 4.3, and again, use my calculator to show me the rest. It's a decay, so I know I have to cross through that y-intercept, come across, and I'm leveling off at that asymptote. So my y-intercept, 0, 13 over 3, leveling off at that y-intercept, or that y-asymptote. Domain, again, never going to stop to the left, never going to stop to the right, so negative to positive. Range, look at your y's, there's nothing down here on the bottom. We start at that asymptote, so we start right here at 1 where we're leveling off. We never touch it, but that's where we start, so we have parentheses, and we continue to go up, so we continue to go to positive infinity. Now, real simple, real quick, just to make sure we can identify growth and decay. Remember again, growth and decay is identified from that b. So when I'm looking at this question, my b is 1.4, so therefore it's greater than 1, so this one would be a growth. The second one, 0.7, is what is attached to that power of x. 0.7 is less than 1, so therefore this one would be a decay. The next one, we're looking at the direction of our graph. We have a function that is decreasing and leveling off. So since our function is decreasing, it is a, let me go back for you, press too many buttons. It won't let me go back, so I'll write it for you. That one is a decay. Do not let yourself get confused on 4. Remember, since this is on the bottom of the axis, all this is telling us is that it's a negative slope. So we have to reference this back up in order to decide if this is a growth or decay. And when I reference this line across the axis to change that slope back positive, I can tell that it's going up. So therefore, this is a growth. The last one, my b, attached to that 2x is 7 over 5. 7 over 5 is a fraction, which is greater than 1. So since that's greater than 1, this is a growth. You guys will have a worksheet, 7.1, 7.2 graphing worksheet with directions on it. Hopefully you enjoyed our first video, and there's plenty more to come. Have a good night.